All right, so now that we have the nodes drawing, we need to deal with the edges. So I'm going to be drawing from the nodes x and y for the first one, so edges first circle, to nodes the second circle's x and y position. Let's just start with a basic version of this, which will be a draw line. And then the arguments are a particular edge, so it's going to be my edge list dot get A is the edge dot get first. Now I have a circle dot get x. Many, many dots. It's going to be the same thing for this particular argument. Edge list dot get A dot get first dot get y. And then we're going to basically do the same two commands, except it's going to be the second one. So I'm going to go get the second circle's x and y. And by the way, this should be edge list, not node list. So to begin with, let me go ahead and just add an edge, just so that I can try it out. Let's see, is that the right way to do this? No, let's go ahead and put in the part where we actually add in the edge. So at the moment, what I'm doing when I release is I check to see if my state is node create. Another thing that I might need to check for is edge first. The idea with this is I need to, if I'm an edge first, I need to check to see if I've clicked within one of my previous nodes. So I need to see if where I clicked is within a circle. I'm going to need to pass in an x and a y coordinate and get back a node from graph panel for this to work out. So I'm going to need to do a command in here inside a graph panel, because it has the list of nodes. Node, get node, and I'm going to pass in an int x and an int y. So given this x and y, how do I figure out if it's within a certain range of one of the circles? So what I'm going to do is I'm going to return, based on node list dot size, a particular node. So let's just get hold of one. So node list dot get A. I need to check to see if the distance from his x and y to this x and y is basically less than my radius. That sounds an awful lot like the Pythagorean theorem. So a squared plus b squared equals c squared. For those of you that don't remember that. So basically what I'm doing is in order for this to work out, I need to subtract the x values and then square them. That'll be my a side. That's the one side of the triangle. And then subtract the y values, and that'll be my b squared side. And then I'm going to take the square root of that. So it may be tempting, many programs say a caret 2 to mean a squared. It turns out Java doesn't do that. That actually means XOR. The only way you would do squared is you do math.pow, which I think is hilarious. And you take your first argument, so x minus node.getX. It can be negative because I'm about to square it, so it's not going to matter. Plus pow, y minus node.getY squared. And then I need to take that whole thing and square root it. These are, I believe pow is going to return a double, so I will be okay with that. Square root returns a double. And so radius is currently that thing. If the radius, basically the distance from the center to this x and y point, is less than my actual radius, then I'm going to, which currently is 20, return node.get a. And if I don't do that, I'm going to return null, basically meaning nothing. Node, you mean node list? Of course you do. I suppose I could just return node. That's just good. Let's do that. And technically I don't need this thing here. It just makes my typing a lot easier in the collision or in the calculation. I keep having this 20 everywhere. I don't like that. It's an arbitrary number. So let me actually put that in. Radius. My radius? Circle radius? Circle radius. So I'm going to put that in there, 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 there. And while I'm here, let's make this multiple lines so I can actually see it. This will become circle radius times 2. And this will become circle radius times 2, so that if I get tired of having such small circles, I can change that. Okay, so the whole reason I did this in the first place was I wanted to make sure that where I clicked was actually in a particular node. So node n equals the panel dot get node e dot get x e dot get y. If n is not equal to null, so if I did get one, that's going to be the first circle that I'm going to highlight eventually, and I need to save that somewhere. So let me put a note up here. So I'm going to set it to null initially. Down here, if I actually get one, first becomes that. My state becomes edge second. And eventually I'm going to need to add highlighting to the circle so I can tell that that circle has been highlighted. Now if I click again on another circle, I'm going to basically do exactly the same thing where I go, hey, did I click in a circle? If it's not null, and probably what I should also do is make sure I don't make an edge to myself. Because these are objects, I have to use the dot equals. You can say equals equals false, or you can just say not that thing. Then I need to actually create an edge. So remove highlighting. Graph panel needs to be able to add an edge, which I don't have yet. Which is going to take a node first, node second, and a string new label. Edge list.add new edge first, second, new label. Okay, so that should redraw or put that back in. It'll repaint at the end of this. So panel.add edge. The first one is first. The second one is now n. And new label is the labels tf.getText. And first should go back to being null. Oh, also, the state is now back to edge first. Let's try it out. Node A, B. Let's create an edge. Click there, click there. Boy, that's awesome.